Hello and welcome to this webcast about modernizing from the inside out. What we want to take you through this afternoon is looking at the various approaches to modernization strategies, particularly for your Z applications, and looking at one specific way of doing that. We're looking at the actual application itself and seeing what can be done from within that application to actually modernize. My name is Chris Backhouse. I am the architect for Operational Decision Manager on ZOS, which is one of the key pillars in modernization. And today, along with two of my colleagues, we're just going to take you through this story. One thing I would say is if you're watching this live, we really are live. We are actually here. There's a question and answer section at the bottom of the panel. If you want to ask us questions, we'll try and answer those as we go along, and we'll try and keep a little bit of time at the end to maybe verbally answer some of the questions to make sure everyone knows what's going on. So with that, let's start. So we've titled this Modernizing from the Inside Out, and a recent Forrester survey showed that 92% of businesses are looking at a modernization strategy. I think a lot of this has obviously been driven from what's happened in the pandemic, and it's a real different way that people are trying to access applications now, with the removal of the interaction with actual people at branches, in banks, insurance, in actually being physically to get to people. There's been a real need for new channels and new ways to get to our core business applications. But I think what's interesting is I think most of us, if we were initially sort of said, oh, modernizing, what does that mean? We would probably say, oh, it's rewriting it into a modern language, be that Java or something else. And it's rebasing it on a modern platform like cloud. But actually, as part of this survey, 58% of those interviewed said that they were at least initially looking at modernizing in place. And that's really where we want to focus at today, is looking at the ways and the advantages of modernizing actually in place with the application itself, because that can often bring a much lower cost and a much lower risk associated with that modernization. So what kind of approaches do we see? Well, often for in-place modernization, one of the key things we're looking at is how to expose the existing assets that we have, particularly on ZOS. These are assets we know and we rely on and we know are working. I mean, let's face it, they've had 40, 50, 60 years of testing and bugs removed from them. We know these are good, solid assets, and we want to make sure that these can be reused. So there's a lot of focus in modernization on how we can get those assets out into the wider organization, using things like ZOS Connect to create RESTful APIs to be able to access these, sort of things like that. There's also quite a drive on how we want to actually develop and get these assets through our staging environments, looking at things like DevOps pipelines. How can we improve that process? How can we speed things up? But they're only as good as the actual application that we are creating in the first place. So if the application we have is not business relevant, if the results it are giving are not competitive for, say, insurance pricing, or new drugs have been brought to the market and they're not known about by the application yet to check for incompatibility with other drugs, or the latest fraud attack is not being covered by this particular application, then the best API in the world and the best DevOps pipeline in the world is not going to help us. So where we want to focus on today is how the core of those business applications, the business policy themselves, can be managed, or in effect, the business decisions that we are making as part of our applications, and how they can be modernized, and how we can draw those out and be able to get the correct actors involved in actually managing and maintaining those. So what do we mean by business decisions? It's a very, very broad term, and it would cover everything from any industry. So in insurance, it might be the claims management or the initial underwriting pricing. In banking, it might be eligibility for loans. It might be pricing of those loans for interest rates. It might be looking at compliance for tax purposes. It might be looking at fraud detection, particularly, say, in the insurance industry, or risk assessment, or auditability and traceability, ensuring that the processes we're doing, maybe, I don't know, in the stock markets, are not are compliant with the regulations that are in place. Or it could be in terms of like loyalty programs or upsell offers. A customer comes to us for a loan for a car. Could we pre-authorize them for the insurance to go with that car? All these kind of things are the kind of things we're talking about. It's the things that make one business successful and one business not. So, for example, if we think about a bank, most banks are largely the same. You have accounts, you probably have loans, you have credit cards. These days you might have insurance. But what makes one bank successful and one bank fail is the difference in how they make those business policies. Are we going to be the kind of bank who go after a large number of small value but high risk loans? Or are we going to be a bank who plays it safe and wants a low number of large loans which are at low risk? Those kind of business decisions are the things that are going to make one business successful and one business not. And that's really the kind of things that we're talking about modernizing here. How can we take those pieces of our applications and modernize them? So there are three priorities driving this area. And the first of these is that ability to adapt quickly. And I'm going to keep coming back to this again and again and again. And you'll see that's even in the title of our presentation today, because this one is so key. One of the problems we've historically had, particularly on ZOS, is the ability to get changes through our systems quickly. We're ZOS people. We like to test. We are the core of the business. And we know that if we go down, the business goes down. So absolutely, we're going to test. But what recent events have shown us is we need to be able to adapt quickly. We need to be able to put new things in place. We need to be able to adapt if we're being undercut by a competitor. We can no longer have a 3-month lag or even a 3-week lag to make a change to our applications. We need that agility to be there here and now as customers are accessing our systems 24/7. We need to be able to increase our efficiency. So gone are the days when a customer is happy to sit there and wait in a waiting area of the bank lobby before they come in and see the manager and ask for a loan. If we're going to ask them to do that, they're just going to find somebody else who they can access on their phone and instantly get a loan. We need speed in these transactions. We need to be able to automate these transactions. Customers want to wait seconds, not days, for a response. But we also need to ensure that what we are doing is totally compliant with regulations. And we need transparency in that. We need to be able to show to auditors that the reason we lent a certain person a certain amount of money was correct based on the regulations. And here is the steps I took in making that decision. And here's why I am correct based on the regulations. So what do our applications often look like today? Well, particularly on ZOS, these business decisions, these business policies will be hard-coded through our applications. And these applications have been around very often for a long time. And of course, the longer things have been around, the more people have been in there, the more layers there are on top of each other. And very often, the simplest way to ensure a particular piece of policy is implemented is just to layer it on top of everything else to make sure it finally happens, rather than trying to search your way through the code and find out where it is. And this leads to very complex applications that are very difficult to make these kind of changes to. And more importantly, applications that are very costly to test. I said earlier, with ZOS, we need to test things. We need to make sure that what we have in production is absolutely stable, absolutely reliable. So we need to make sure these are tested. Now, I'm the product architect for Operations System Manager for ZOS. Whenever we make any small change to that code, before it goes out of the door, it will receive a full regression test and a full set of testing, because we don't know what effects that's had. So any even small change we might make to our business applications, we know there's going to be a large complex testing cycle to ensure that we haven't broken anything else in the application, even just by recompiling it. It also leads to the fact that the business teams can often feel quite detached from the changes they're wanting to make, because the first thing they have to ask the question is, Where's this application running? Am I going to our cloud team? Am I going to our distributed team? Am I going to our ZOS team? Where are these applications running that I need to make a change to? And that just isn't logical. So what's another approach to this? Well, what we can do is look at these applications and look at the bits that are changing regularly. If we think about an application, we have a data layer in a database. It's a fairly big change to make a change there. We have an interface to it, be it a RESTful interface, be it a 3270 interface, be it a web interface. Often a change to that is going to be quite a major interface because it's going to require changes to other applications or retraining of people who use those interfaces. But the bits that change regularly are those business decisions, those business policies. Someone's suddenly undercutting us with their insurance rates, so we have to respond and put a special offer in place that makes sure we align with their rates or undercut them again. We're in retail and someone suddenly is undercutting our prices. We need to change our price or put special offers in place to encourage people back to our business. Or we're in the health sector and new drugs are coming out all the time, or new reports show incompatibilities between certain drugs. It's imperative that we get that into our systems that do our dispensing as quickly as possible to ensure that our risk is as little as possible. So what we can look at doing is maybe taking that logic, just that logic that implements the business decisions, and moving it out into a separate system that is designed purely for managing and maintaining that kind of information at a level of abstraction that makes sense to the actors who know about that. If we could have the policymaker who understands what the pricing rules need to be or what the fraud checks need to be directly involved in the process, we miss out an opportunity for mistakes to happen. All too often, in the old way of doing things, we might not realize we've not put the right policy in place until a long way down the line when we're analyzing results, maybe months later, and we realize that our, say, risk profile isn't what we were expecting it to be. If we could have the business people involved in the process right from the get-go, then we have a much better chance of ensuring that what we have in place is what we should have in place and what we need to have in place. So IBM's solution to this problem is IBM Operational Decision Manager for ZOS, which is basically a decision management platform that allows you to take and write business rules to implement those business policies. And the key three things are the ability to write those rules in a way that is understandable by anybody who needs to see them. So if we're trying to show a business person and say, is this what you meant? And even though the B in COBOL is supposed to stand for business, I don't think we're going to expect a business person to understand that. But is there a way we can have something which they can directly interact with, which they can validate as the source of what we're actually going to be running? And the answer is yes, we can do that with ODM. Agility, we need to be able to reduce that life cycle of making changes and getting those changes into production. And auditability, we need to be clear. We need to see who's done what, how they did it, why they did it, and be able to potentially roll back if what they've done is not what we wanted. So a couple of quick examples just to kick off with to show that this is possible. This is not pie in the sky. We have customers running with this in production. So we had a large financial customer who was using, had a very, very large application for creating the statements that people have for their investments. I didn't realize there's a huge amount of regulations around this, about how frequently you have to have these statements, about what's in these statements. And they had a huge COBOL batch application. They modernized this application into Java, moving it into the batch container of WebSphere application server. And at the same time, they moved all that business policy logic, the business decisioning, out into ODM. And the key thing to take away from this is their change cycle went from being 9 months to 6 weeks. Now, obviously, that's a huge cost reduction for them. But more than that, the key thing for them was, as we all know, COBOL skills particularly, and ZOS skills are becoming more and more precious. So they freed up almost 7.5 months worth of precious COBOL development skills that they could use going after revenue generating projects, putting out new channels to the market, new products, rather than just managing and maintaining a very large existing statement system. Another customer we had was an insurance company in Europe. And the key thing here was they managed to take an application that they had originally built for a cloud-like environment, and that was their online environment, and they wanted their overnight batch renewal quotes to be done on ZOS, but using the same decisioning system and the same rules associated. They could change their rules once in one place and push them out to both platforms. So I don't know if you've ever tried to make a Java application give the same mathematical results as COBOL or C or pick your language. It become very, very complicated. But with ODM, they were able to get the same results from both a distributed or cloud-like environment and a ZOS environment. And another key takeaway from here is that this project went from inception to production in 4 months. So what we're talking about here is not throwing everything out and starting from scratch. This is something that incrementally can be brought in, and we can start seeing return on our investment fairly early. So the key to this is that we are not just talking about business rules. We're not just talking about business decisions, but the whole life cycle associated with those. The fact that we need to capture what those rules are in a way that can be understood. We need to manage those through a development and a deployment and a life cycle. We need to obviously execute those and automate them. And then we need to look at what decisions we're making and ensure those decisions are correct. So the first step in this is capture. We need to be able to get those rules written in such a way that they can be understood. As I said, the B in COBOL was supposed to stand for business. It was supposed to be a language that could be understood by the business. But I very rarely see any COBOL code I can understand immediately without some level of documentation, let alone think about putting that in front of a business customer. So what we want to do is have something, and what you see here are examples of business rules. At the top half of this slide, we can write a rule like if the area number of the social security number of the borrower is one of a certain value, then start applying conditions to that and applying actions that we want to take. And the key here is with ODM, we can create this language, but then we don't expect you to learn the language. The editors will guide you through. So actually, if you were writing this rule, probably the only things you would physically have to type would be if, then, else, and the actual values you want to put in, like the 000, or the messages that you want to put out into the actual loan report. So it's a very easy solution to come up to speed with. And this is also a way of looking at business rules. So here we have a bank loan, and you could look at this as being 2 parameters we're looking at with a couple of ranges of values. So for example, if the loan duration in years is between 5 and 8, and the loan value is between 0 and 0.7% of the income, then we charge a certain percentage rate. It's very easy to see what the rules here are, what these values are, how easy it is to change them on the right-hand side. Now, this is obviously a very simple decision, looking at it in this way, but I hope you can imagine if we transpose this into COBOL code, we've probably already got 3 or 4 pages worth of nested if-then statements based on the ranges that we've got here. And if someone wanted to change one of these values, it becomes a much harder process and actually something that you're going to want to do a large amount more testing with. This looks like a spreadsheet table. And actually, with the ODM tooling, we can bring these rules, as you see here, actually in and out of spreadsheets so they can be managed and maintained in the way that the business team are probably already managing and maintaining these rules. And I've mentioned managing and maintaining many times. This is the key point here. We need to have a life cycle which is governed. We need to know who's doing what, when they're doing it. We need a repository. We need versioning. So ODM provides a repository where all of the decisions can be placed. And this is very similar to what you'd have in a source code repository. So we can see every decision that's available, or can we? This is role-based, so I may be part of the pricing team, which means I can only see and access that decision for pricing, and all the others are available to other members of the team. So everything is governed with access, governed with what I can do, governed with who can make a change. Every change is logged, and I can see what changes are made and who made them. And these are made through this environment, again, with these intelligent editors. This is a web-based interface, so it's very easy to access. As I say, it's log-on and role-based, and we have those full editors available to guide you through the development, management, and maintenance of the rules. And as I make a change, I can see through the timeline who's made a change, why they've made a change, what change they've made. And I can even compare two versions side by side and see what changes have been made and why they've been made. So I can roll forward changes or roll back changes if something's gone into production that I wasn't expecting. But a key part of that is ensuring, again, we're Z people, is testing, testing, testing. But what we want to be able to do here is test the changes we're making to our business decisions in isolation from the rest of the application. So we want a way to easily and quickly make a change, see what the impact of that change is, make another change, see what the impact of the change is. Am I getting the right results? But at that abstraction of, I'm thinking about this just at the level of the business decision. If I make this change to the pricing rules, am I getting the correct prices back? I've got a new fraudulent situation I've identified. If I put these changes in place, am I going to pick up on what that fraudulent situation is and actually flag it for further investigation or not? And the advantage is we can run these decisions time and time and time again, actually outside of our ZOS environments, within the test environments, within ODM, knowing that the results we get from those test environments, we can be assured are going to be the same results for the same input data once we're running inside our ZOS environment itself. And that means we can actually deploy into our production environments much, much more safely. So we have many customers who are deploying new versions of decisions multiple times a day directly into their production environments, knowing that the only impact they will have is to a business result, a bit of data coming back, nothing that's going to take the systems down, nothing that's going to cause any IT type problems. And they know they're going to get the right result back because they've been able to extensively test it just in that isolation before they get there. So the third step in this is execution. And what I want you to note here is this isn't where I started. This is the third step. And I'm not saying it's not important, but many business rule systems, many ways of doing this decision automation, the whole focus is on the execution at the expense of the authoring and the management. And so here we have a really great execution environment. It's really high performance. I mean, in our tests, we're running up to 96,000 transactions a second on a 4-engine, I think that's even a Z13, we were getting those numbers on. So much larger now in our current systems. But we can run, but the key is not just having a good execution environment, but actually having that ability to have the full life cycle. Now, again, our solution for ODM on ZOS is not just a lift and shift of a distributed environment. We've tried to tailor the environment so we have clear, easy integration with, yes, if you're running in a WebSphere Liberty on ZOS, you can run your Java applications in exactly the same way you would do on a distributed environment. But also, we have the ability to integrate directly with your CICS, COBOL, or PL1 applications, your IMS COBOL or PL1 applications, and that's running both online and batch transactions, and also to integrate obviously with key workload on ZOS, those ZOS batch jobs. And this is all done high speed within the LPAR. There's no APIs going on here. This is all done cross memory, high speed, with all the execution of the rules themselves happening in a Java, so offloadable environment. So you also have the ability here potentially to get some cost savings by being able to move some general processing out onto offload eligible Java workload. And one of the keys to doing this is the fact that this is seamless to the COBOL programmer. So we've created a very simple COBOL API, 3 verbs: connect, execute the rules, and disconnect. And the code you see here on the right-hand side is, if you like, the minimal amount of code that you need to have in place to actually execute a decision on ZOS. So I hope you can see that it's fairly straightforward for this not only to integrate into the ZOS environment. We have a very small footprint address space that can run and integrate with those CICS, ZOS batch, and IMS environments, and also actually potentially DB2 stored procedures. But we also have an interface to that that's clear and easy and simple to integrate with those CICS batch and IMS applications in both COBOL and PL1. And then the final piece of the puzzle is the need to actually see what decisions we're making, to be able to look across. And here within the Cloud Platform Business Automation, we have the ability using business automation insights to actually plug our rule execution into a dashboard that allows us to see across periods of time, are we suddenly not accepting a large number of quotes that are coming in? What's changed? Has the demographic changed, or has our rules changed? We're suddenly seeing our number of claims accepted going through the roof. Is there a new fraudulent attack that we've missed? Here's something that the business teams can actually look at, to look at the decisions we are making over a period of time, to allow them to help to work out what the decisions should be going forward. So just to land this very quick introduction, I understand, on ODM with a couple of examples. So we have Brownells, who were a customer who were very, very heavily regulation focused, and they were having difficulties with the fact that a lot of these regulations needing to be actually implemented by person rather than by automation. And they were able to get a 300% increase in throughput moving to ODM. PNC Bank took over another bank, and they were able to create huge efficiencies by, as they brought those systems together, moving it into ODM. We've seen an increase in productivity through claims at Control Expert just by that automation. And we also had in the NHS in the UK using ODM as a way of optimizing who's available for transplants. So actually looking at the organs that are available, looking at the people who would need them, and optimizing so the right organ gets to the right person to have the best outcome of life, and seeing actually a really great improvement in the success rate and the survival rate, more importantly, of those patients. So ODM is something that can be used across all industries. Anywhere you're making a business decision, potentially we can get business teams directly involved in making those decisions, potentially freeing up a large amount of our precious ZOS resource and allowing that to go after revenue generating opportunities than just having to manage and maintain these business policies that are just kind of, an update to this decision here, an update to that decision there, which quite frankly, as a developer, is not very interesting. But also, I would far rather, as a business person, know I'm going after new opportunities. But this all sounds great. What if my starting point is that very complex, overlaid, spaghetti, if you like, code, and I want to try and get to this sort of utopian stage B that you have talked about, where everything is running separately and what's left is more stable because it's changing left, and I have this great life cycle? How do I get there? Is there anything to help me? And at this point, I'd like to hand over to Mark Indermaur, who's going to tell us a bit about IBM ADDI and how it can help us actually get through that stage.
Thank you, Chris. I'm a product manager on IBM Application Discovery and Delivery Intelligence, ADDI. And we've been working with Chris and his team for several years on this very topic. So ADDI is an application discovery and analysis tool. It analyzes source code and related artifacts for COBOL, PL1, Java, Assembler, and Natural. And it saves the metadata from that analysis in a repository. And then we use that repository to provide a broad variety of graphical analysis, visualization, as well as reports. So this helps developers understand an application, understand the potential impact of a change before they make it, so they can more accurately plan those changes, make the changes more quickly, and with a greater degree of confidence. This is especially helpful for new developers they may be experienced developers, but they may be new to working with COBOL and ZOS applications. And this enables them to understand and learn those applications much more quickly, and they can become productive members of your team in a very short period of time. So some of the areas that you can imagine, this type of information is useful in any type of application modernization, but it's particularly useful for finding business rule and API candidates. And we've also been using it in a variety of other ways, even in data modernization. Today, we're going to focus on how we're helping with identifying business rules. So what we've done specifically with ODM is add a business rule discovery capability to ADDI. We've done this in a web UI that's designed to be used by both business analysts and developers. And in addition to analyzing the source code, as I mentioned before, it will also analyze any documentation that you have for the application, because the documentation may be a useful source for information about business terms and business rules. We'll support both a top-down and a bottoms-up discovery of this. So if there are specific rules that you're looking for and you have some clues as to what variables or data fields might be involved, then you could do a tops-down search for those. If instead you're doing something like the scenario that Chris described of the financial institution that was updating their statement application, there, if you're re-implementing the entire application, you may actually want to do a more thorough bottoms-up type of discovery. So the kind of the steps involved here, you analyze the source code and documentation, and now you're exploring for keywords. These keywords are variables, parameters, data fields, and you can rank how those show up, because you can imagine in a typical typical ZOS application, you could have hundreds or thousands of programs, each that could be of substantial size. So you could have thousands or tens of thousands of potential keywords. But if you could rank those based on how often they appear in conditional statements or in calculations, or how often they're used in data I/O, and you can decide the weighting for each of these different factors, then you can very quickly get the most relevant types of potential business terms at the top of your list. Then we have a business term catalog. So as you identify a keyword that actually that implements a business term, then you can designate it like that and add it to this catalog. You'll find, especially in an application that may have hundreds of programs, each of those programs might have a different keyword or different variable name that implements that same business term. So you can identify synonyms for the terms. And then once you've found a few terms, we provide affinity analysis. So now you can see, well, what other keywords appear frequently with these now identified business terms. So you can very quickly find the other relevant business terms. The final step here is then to get to the business rule. And this is where you're looking at the code snippets that use those business terms. And here you're particularly looking at things that are like conditional statements or calculations. And you want to capture those or document those code snippets in what we define as a business rule package. And then that's the information that you would need then to implement that business rule, that business decision in ODM. This is a quick introduction, and I'd like to now turn it over to Rami Katan, who is a senior technical staff member on our Z DevOps team. He's a chief architect, was originally the chief architect for ADDI, and he's now also working on applying artificial intelligence and machine learning for Z DevOps. So Rami, let me turn it over to you for a demo.
When coming to expose application business logic via ODM decisions like Chris described, there are three key things you need. First is to identify the application business terms corresponding to the key program variables or records out of the many thousands existing in the application. Second is to capture the key business rules of the application. So essentially, the code snippets with the relevant logic of the business rules. And third is to do that at scale, with speed, accuracy, and with a good interface for business analysts and SMEs to confirm and advance on taking it into ODM. ADDI, Business Rule Discovery, covers all that, with machine learning over application documentation and with rich context analysis and usage statistics from the source code. ADDI Business Rule Discovery, BRD as the acronym, is part of the ADDI web client. Each BRD workbook is mapped to an ADDI project, which contains source code analysis of an application. Let's dive into what it can do on a hospital management application written in COBOL. The workbook includes three key areas. Keyword exploration that lists keywords of the application source code and keywords of the documentation available. A business term catalog, which lists business terms discovered where a business term has a definition, it has implementation name, different variables or records mapped to it, a status, and key snippets that use that business term. The third area is business rule packages area, where you collect different business rule packages comprised of code snippets in an order that represents the business rule. Let's see them closer and see how they help you determine the business rules for ODM. Starting with keyword exploration, I start not from the source code, but from the documentation. First, let's see what we have in this view. So we could see that out of the source code, ADDI has identified 733 keywords coming from the source code. The documentation of the application comprised of PowerPoints, PDFs, Word documents, and other text or JSON or XML formats. ADDI found 2,284 keywords in them. And already using ADDI, we discovered or we classified 21 associated snippets for 10 different business terms. Looking at the keyword exploration from enterprise artifacts allow us to see what ADDI is doing with machine learning on top of the documentation. ADDI runs NLP, natural language processing, on the application documents. It identifies keywords, it groups them, and it finds the relations between them to allow for smart content indexing. What we see here is different keyword names grouped with similar keywords coming from the documentation. And we can see the number of artifacts using them and number of times it's defining an artifact. So essentially we have here a dictionary of the different keywords from the application documentation, allowing us to identify what this application is doing, what are the key business terms in it, and lead us to looking for specific variables or records in the application. Now, this capability is really nice because it gets you from a starting point where you may not know the source code at all, but you do have some documentation. By identifying that patient ID is a key element in the documentation and where it's defined, allows you to see all the places where it's defined in documentation. And here you can see already documentation detailing some JSON RESTful services that are providing data from the application using patient ID. All that is part of the documentation that you can see, map, and attach to business terms as well. Coming to understand what you've got in the business terms leads you to looking for these keywords in the variables defined in the application. So the other part of what we have here is the smart indexing of all the application variables and records, where we see that they are ranked in some predefined order that you can control. Each keyword here represents a variable name, where you can see how many times it's used in different conditions and computations and IOs in the application and how many programs are using it. This actually, when it's ranked, allows you to see the top variables and top records in the application. Scrolling down, we can see here different things that are important in the hospital management system, such as treatment mode, patient record type, total room charge, patient total amount, equipment ID, and other keywords. This is just a start, and what you can see here is also the statistics of their usage. Looking into every variable allows us to see what programs and how programs are using the variable. Let's get into seeing patient total amount. ADDI identifies that it's defined in an include file shared by 6 programs and also defined as a local variable in 2 other programs. When looking at the detailed usage, we can see, for instance, that this program is using this variable in a read statement 2 times, in a move statement 2 times, and also with 2 compute statements. The interesting thing here is that we could get directly to the formula that computes patient total amount. So you can see patient total amount is a formula comprised of other elements that are computed previously in this program or previously in the application. Trying to track that and identify that this is a key business term in the application allows us to say, let's collect this code snippet as a relevant snippet for patient total amount and maybe for other business terms that are mentioned here. And let's also track the variables that are part of this computation so that we could get that back into a business rule package. So ADDI not only allows you to see the code snippets and associate them with a business term, one or more, to create business terms on the fly as you go, it also associates these in a flow of code snippets that allow you to find the full business rule. When looking into patient total amount and identifying this is a key application concept, I can create it as a new business term, or I can associate it with existing other business terms as well. Another interesting functionality ADDI offers is affinity, where once you discover that this patient total amount is a key business term in the application, you can look for other terms that are with affinity to it, that are used together with it in the application. So by finding a subset of the keywords in the application, you have a starting point to discover with affinity other related key business terms in the application. So for instance, we could see that total room charge, medication charges, pharmacy charges are all used together with patient total amount, and they can be business terms by their own. And the way they are computed could be a small business rule or an ODN decision by itself. When you click on variables that are used together with it, you can go and see where they are used together. So the affinity leads you to see the places, the programs and the statements that use both variables together to show you why they are related. In this case, you could see that patient total amount is moved to total charges. If we're looking at the relation to medication charges, we can see an add statement where ancillary charges and medication charges and pharmacy charges are added to patient total amount. So together, this allows us to find more keywords in the application and map them into business terms. So the keyword discovery allows us to identify the variables, but we can also search for variables. So if we know that we're looking for specific charges, just by typing the word charges, just by typing charges in the keyword exploration allows us to see all variables that have the word charges in them. So we could identify out of the variable dictionary or record dictionary in the application, you can discover other keywords and associate them and start a new business term out of them directly. When we associate business terms, we collect them in business term catalog. And the business term catalog is a place where we can say this application contains these business terms. These are the key snippets for these business terms. Maybe as we go and analyze the application, we identify that a certain business term has more than one name that represents the same meaning. So we associate more keywords and more variables and records with the business term to collect that information in one place. The business rule package is where we associate several business terms with a whole flow. For instance, computation of patient total amount, which we just saw earlier, is actually using multiple business terms like primary care physician ID, patient total amount, equipment charges, lab charges, reimbursement percentage, and state factor. All of them are separate business terms that we've identified, but together they are one business rule flow, which could be taken as is into an ODM decision. So let's look at how a business rule package looks like. So business rule package is a series of ordered code snippets that we collect and associate. We can add more code snippets from the source code into this business rule package and then put it in the right order. And what we can see here is that the first code snippet here is the code snippet that computes the lab charges in a loop. That's something that was discovered earlier using a lab charges keyword, lab charges business term identification. So this code snippet looked to be relevant for that, and lab charges plays a role in the full computation of patient total amount. So this piece here is the first code element that is required to compute the total patient amount. The second code snippet here computes the equipment charges. The third is a decision whether this patient is in network or not in network or out of network. The next snippet is part of providing a constant to the reimbursement percentage when in network. Then several values are provided for the state factor. So depending on the state, you get a different state factor that will enter the formula. This is kind of logic that would go into an ODM decision table and is classic to be managed outside of the source code by a business analyst. The next piece in the business rule package is the formula itself, where patient total amount is already using values that were pre-computed, and at the end of that line, the patient total amount when in network is being computed. Now, ADDI collects here all the source pieces. They could come from a single program, they could come from multiple programs in the flow, but they are what's required as the business logic into the ODM decision. And by that, and by providing a full catalog for all business rules collected by multiple team members as an effort for identifying or modernizing an application, multiple business terms and business rules can be detected. A business analyst can go over these rule packages together with an SME, confirming that all the source code relevant for the business rule exists here, and then taking the source code and the logic into ODM in the way that Chris described before allows you to have that logic as is with all the business rule logic from the source code in ODM. You could then change it, manage it in a different way, and then also you could refactor the code. So the places in the code here that are relevant for the business rule package will be taken out of the code, and instead of them, there will be a call providing the customer record or the patient record into ODM and providing the patient total amount as a return value. So looking at what we have here, we've come to understand that we can identify, even in very large applications, the keywords, the key keywords in them, map them into business terms, and go forward with business rule packages. One thing that I wanted to show you is that when you start the keyword exploration, you don't have to know what are the key variables in the application. One way for you to control the list that is returned here is to provide different weights for how variables are being listed. Now, my current order in the list that you've just seen was putting variables that are used in computations as the high scoring or ranking criteria, with second criteria being the usage in conditions. Now, by changing this, for instance, taking computations down, taking conditions up, and taking file IO up, I'll be getting a different list when I look at the full variables of the application. And right now I'll get to see variables that are heavily used in conditions, but also are playing a role being written or read from a file. And by saving that and getting into my workbook, now all my keywords in the applications are ranked according to my new preferences. You could see that patient ID comes first here with 8 conditions and 31 file IOs. But then I get new values that I didn't see before, ranked higher, and then they could be part of new business terms that I didn't have until now that may be playing a key role in the application based on their usage. So the key thing here is that ADDI does not care for the actual content of the variable name, but it cares for the usage statistics. And the logic would be that because it's used heavily in conditions and in file IO, it means that it plays a key role in the application. Therefore, you might want to notice it, might want to map it into a new business term and follow it as part of your work trying to modernize the application with ODM. So that concludes the short demo, and Chris will follow up with his insights on how this helps you forward with ODM. Thank you.
Thank you, Rami, for that demo. That was really helpful to actually see it. I don't know what it's like with you, but I often find that physically seeing something makes it far more understandable than just seeing some slides. So what we've taken you through today is a very, very high level, very, very quick look at another approach to application modernization that you might not have been thinking about, the approach of modernizing from the inside out, looking at the applications themselves and seeing what within those applications could be externalized into something like ODM and managed on a different life cycle, managed with the actors who actually have a direct interest and control, maybe getting the business teams themselves directly involved in that management, in that maintenance of those decisions. And if this was something you were looking at doing, you would be in good company. We have ODM customers, 4 out of every 5 of the top worldwide retailers, 60% of the top 20 banks in the world, etc. There are large numbers of large customers running huge volumes of transactions and gaining benefit from this approach every day. But I also realize this has been a very, very quick introduction to both of these topics, the 2 very large topics. And we've probably raised more questions than we've actually managed to answer. So if you would like to know more, I would recommend going to our websites where you can see more in-depth information, more customer use cases about both ODM and about ADDI. We actually have a Forrester Wave of digital decisioning. I'd really recommend you go and have a look at that. And for ADDI, we have a Forrester report on the economic impact, which is a really good read. One thing I can't recommend enough, though, is these things really start to make sense when you get hands-on with them. And if you've not seen the Z trial capabilities, I really strongly recommend you go and look at those. We've got Z trials from everything from Kix to IMS to WebSphere to machine learning, but obviously we also have them for ODM and ADDI. And this is basically an environment that will be provisioned for you for 3 days, where you can get hands-on and actually have a go at working through some simple scenarios with both ODM and with ADDI to really see some of what we've been talking about. And if you would like to know more, tomorrow we have an ADDI customer who is actually talking about how they have been gaining benefit really in using ODM. So you can see this is real. This is not just us talking propaganda. There are real customers getting real benefit from this. If you'd like to know more about ODM, next week we have another webinar where we're particularly looking at how ODM and machine learning can work hand in hand to create real dynamic decisioning for you. And again, I really recommend that if you haven't registered for it yet and you're a Z person, you really should register for the IBM Z Day virtual conference on April the 5th. It'll be a great day. There's some really good speakers lined up for that and will be a really great place. So with that, I want to say thank you for joining us today. If you have further questions, please feel free to contact us. I believe these slides and other information will be made available to you. So thank you for joining us, and I hope some of that was useful today. And thank you very much, Mark and Rami, for joining me in this.